Hello everyone. Today we are going to talk about a very interesting topic, which is statistical analysis for predicting the range of E-Rikshaw. In this paper, basically we are going to talk about some statistical analysis technique, which is design of experimentation and regression analysis. And by using this technique, we are going to find the total distance traveled by E-Rikshaw if three independent important variables of this system is changed. In this paper, we have also proposed a completely new and innovative storage device for an electric vehicle. The presentation is done by me, Vispi Karkaria from Mechanical Engineering Department of College of Engineering, Pune. And the paper which I have taken is statistical analysis for predicting the range of E-Rikshaw. The authors of this paper are V Kokate, V Karkaria, which is myself, J Bhalerao, and Dr. B Karandikar. This paper has been presented in IEEE conference on power electronics application and technology in present energy scenario in NIT Surathkal in September 2019, and this paper will be uploaded on IEEE Express. Now, let's see the motivation and objective of this topic. As the pollution is increasing day by day, the need of using electric vehicle is also increasing. However, there are a lot of problems when we create one solution, and there has to be solutions for that problem. So the main problem in this thing is the charging time of the batteries. A regular electric vehicle takes too much time to get charged, which can be inconvenient for the user. So the solution of this problem is that we can use supercapacitors along with batteries to increase the life of the car. So let me try to make you understand what we are doing exactly. When we start the vehicle, high amount of current is consumed from the batteries to start the vehicle, as the starting spark needs more current, so the batteries gets drained very fast at the initial stage. This may also lead to the damage of the battery. So in this case, we will replace battery with supercapacitor for initial starting of the vehicle, so that the high amount of current can be given by the supercapacitor. Supercapacitors has the capacity to give high current, and one more advantage that supercapacitors have is that they can get charged in just 5 or 10 minutes. So if we use a combo of the system of a supercapacitor and a battery, the size of this electric storage device reduces, and the charging time also gets increased and discharging time gets reduced. Discharging time gets reduced, that means we can travel more distance. So in this way, this is a solution. But now we'll do some important analysis for this research work. This is our flow chart. First of all, we have studied the previous work on this subject. Now we'll find the independent variables which has more impact on the dependent variable, which is the distance traveled by the e-rickshaw. We'll make a complete DOE full factorial sample plan. Before any research or any analysis, we have to create a sample plan and then do research accordingly. We'll conduct the experiments according to the DOE sample plan. We'll do check of multicollinearity. That means we'll check if the independent variables that we have selected are correct or not. Then we'll find the regression equation with the help of multi-regression algorithm, and then we'll see the analyze the r square value and the p value. If it is not satisfying, we'll do the analysis again, and if it satisfies, that means our analysis is correct. Then we'll finalize the regression equation and finish this paper. Now let's go on to the objective of this paper. The main objective of this paper is to get the optimized results so that our electric rickshaw travels the maximum distance. Basically, we'll give a prescribed value of the independent variables to a consumer and to the manufacturer for getting optimized results. The three independent variables which are the most important for designing an electric rickshaw is rated speed of PMDC motor. Second is the battery capacity in ampere hours. That means the capacity of energy that can be stored in the battery. And the third important parameter is the capacitance of the supercapacitor. The dependent variable is of course the distance traveled by E-Rikshaw. And for doing all these experiments, we have made a scaled down model of E-Rikshaw by a scaling factor of 66. Now let us talk about what is design of experimentation. Basically, before any experimentation, we have to create a very good plan so that we can get the maximum efficiency from the analysis. There are two different main type of categorization for design of experimentation sampling plans. First is orthogonal designs. In these samples, all the samples are taken in a proper orderly manner so that the whole sample space is covered. The different type of orthogonal designs are full factorial design, central composite designs, and box Benkem designs. The second category are random designs. These are used when there is a very huge sample plan and it is insufficient to carry out a complete orthogonal design. So by randomized algorithms, we select specific points so that the whole sample space is covered and then sampling is done. The two design techniques are Monte Carlo method and Latin hypercube method. Now for our experimentation, we have taken a full factorial method. The reason is that we want to know that what is happening in our complete design space. So in our case, we have three factors, which is the rated speed of PMDC motor, the battery capacity, and the supercapacitor capacitance. And two levels have been chosen for each of these factors. According to that, the formula for DOE is number of levels raised to number of factors. So in our case, it's 2 raised to 3. That means we are creating 8 samples. Now, this is the DOE table which has been created. The two levels for rated speed of PMDC motor is 100 and 300 RPM. For battery capacity, it's 1.3 and 3.3 ampere hour. And for supercapacitor capacitance, it is 8 farad and 16 farad. Experimentally, we have found out that the total distance covered is as given in the table. Now, we move on to regression analysis. Regression analysis in simple language is a line fitting or a graph fitting method in which we try to put or try to fit an expression or a surface or a graph to the sample points so that we can get the best fit as shown in the GIF. For our technique, we are using multiple regression as we have three independent variables and we are using polynomial regression so that we can get better results. The software used in this research is StatsGraphic and Minitab. Before going for regression analysis, we have to check the multicollinearity of our independent variables. Basically, it shows that if there is a relation between the independent variables for a good sample plan, there should be no relation between the independent variables. So by this technique, we can see whether the independent variables that we have chosen are correct or not. We have used variance inflation factor. So in statistics, the variation inflation factor is a quotient of the variance in a model with multiple terms by the variance of a model with one term alone. It quantifies the severity of multicollinearity in an ordinary least square regression analysis. It provides an index that measures how much the variance of an esteemed regression coefficient is increased because of collinearity. Go on to the testing. This is the part 1 where we have taken total distance covered versus the rated speed of PMDC motor. In simple, if we see this graph, we can see that there is no relation created between the two independent variables. So in short, there is no problem of multicollinearity and the VIF value is 1. If we have VIF value 1, that means there is no dependency upon the independent variables. But if it is more than 1, that means that we have some problem, that we have some dependence between the two independent variables. Here also we are comparing total distance covered versus the rated speed of PMDC motor and supercapacitor capacitance. Here also no relation is made and the VIF for all the constants is 1. So this is also safe. Independent variable relation also shows that there is no relation made and the VIF values are also 1. So in short, the independent variables which we have chosen for our analysis are. Now let us see what the results we have obtained for our regression analysis. This is the equation that we have achieved, which is minus 440 minus 0.1 n plus 522 into BC plus 75.4 into F plus 0.6 into n into BC plus 0.08 into n into F minus 42 into BC into F. The R square value of this equation is 88.87. The R square value in short gives us an idea about how good the variance is there in our graph. As the R square value reaches to 100%, that means the variance or the variation from the actual model and the statistical model is very less. In our in our analysis, the R square value is 88.87%. It is prescribed to have a R square value more than 80%. So our model is good. R square adjusted value is 86.67. R square adjusted gives us the idea about the variance between the independent variables and R square predicted value is 85.98. This value is used while calculating the predictions which we made from the regression equation. The standard error which we get is 120 and the mean absolute error is 60. One important thing I want to state is that the overfitting. The R square value should also not be 100%. If it's 100%, it shows that the variables which we have are very less and our model is poor. So for having a good model, our R square value should range from 85 to 98%. These are the analysis which we have done of our complete model. This is the standard Pareto chart which shows the significance of each and every independent variable individually or together on our dependent variable. From this graph, we can see that the rated speed or the battery capacity of the capacitor has a good amount of significance. But the supercapacitor capacitance has very less effect, means it is completely insignificant, but we cannot neglect supercapacitors capacitance as in the second, which is BC, the capacitance has having a significant amount of importance in the equation. In this graph, the gray boxes signifies that the distance traveled by e-rickshaw is increasing, which means it has positive effect, and the blue boxes signifies that it has negative effect, means the e-rickshaw travels less distance as this parameters increases. Now let's move on to the p-value in our regression analysis. Basically, the p-value helps us to determine the significance of our regression equation. That means it shows us that how much significant or how much truthful is our independent variables. The p-value should always be less than 0.05. That means it has good significance. In our model, the A, B and C parameters are having good p-value, but the C, AB and AC are not having good p-values. That means we should neglect these three parameters. there is a main effect plot which has been shown inside. Here, the RPM and the battery capacity in AMPH has a positive slope, and the slope is also more. That signifies that they have more impact on the regression equation. On the other hand, the supercapacitor capacitance has a very less slope. That means we can neglect it as it has very less effect on our final output. So by all these modifications, we get a new regression equation, which is minus 440 minus 0.1 into n plus 522 into BC minus 42 into BC into F. This is a complete flow chart of a regression equation. First of all, we take the given data from the DOE sampling plan. Then if we check that if the data is correct or not, means we check about the multicollinearity. Then we solve this regression equation by regression solver. If the R square value is less than 80%, then we go to the data again, we improve the data, we get more data and try to increase our R square value. Then we check the p values of our coefficient. If they are more than 0.05, then we neglect it, and if it is less than 0.05, then we move on with the equation, and finally we get our final regression equation. Now let's see some 3D analysis of our model. On the left hand side we have the 3D graph, and on the right hand side we have the contour charts. Here we have taken capacitance as constant, as capacitance has very less significance. From the 3D graph we can infer that as we increase the AMPH of the battery and the speed covered by the electric motor, we get more distance traveled by E-Rikshaw. Now, at last, let's see the conclusion. From this complete presentation, we have learned how to assign and carry out a successful full factorial design of experimentation sampling plan. From this, we have also learned how to create a regression equation and how to analyze the equation which we have achieved. And in this way, at last, we have created an equation from which we can get the maximum distance which can be traveled by electric rickshaw. The references of this presentation is the paper which we have referred mainly is statistical analysis for predicting the range of e-rickshaw, and also for numerical methods we have used the Numerical Methods book for engineers by Stephen Chapra and Raymond Canal of Tata McGraw-Hill publication. These are some important definitions which I wanted to tell you in the ending. First of all, let's see what is design of experimentation. The design of experimentation is a design of any task that aims to describe or explain the variation of information under conditions that are hypothesized to reflect variation. What is regression analysis? In statistical modeling, regression analysis is a step of statistical process for estimating relationships among variables. Now let us see what is coefficient of determination or R square value. In statistics, the coefficient of determination is the proportion of the variance in the dependent variable that is predictable from the independent variable. Another important definition is about the null hypothesis. The null hypothesis is a general statement or default position that there is nothing new happening in that area, like there is no association with any other groups or no relationship between two measured phenomena. At last, let us see the p-value. The p-value is the level of marginal significance within a statistical hypothesis test, representing the probability of the occurrence of an event. The p-value is used as an alternative to rejection point to provide the smallest level of significance at which the null hypothesis would be rejected. A smaller p-value means that there is a stronger evidence in favor of the alternative hypothesis. We have also made a Python code for verifying our answers, and we have verified it with success. This is a Python code. The first page, second page. You can refer this Python code also for your convenience. Thank you for watching.